All right, welcome to the video on factoring by grouping and the sum and difference of cubes. These are both methods of factoring. I've talked about both, but we haven't seen in examples that were like, you have to do it that way. So now we're gonna see that today. We use factoring by grouping when you see four terms. For example, here are four terms right here, so we try to factor it by grouping. Now, some of you, when you have three terms, you break it into four terms and then factor by grouping. So this is gonna be a nice, easy lesson for you. And then also, I've talked about the sum and difference of cubes, factoring that, and we are gonna learn that. So when we get to our next section, it's a little easier to do some problems. Okay, so let's get an idea of what factoring by grouping is like. So when you see four terms, you're gonna try to factor it by grouping. Step number one is you're gonna group the first two terms together and the second two terms together. So it looks like that. After looking at your first two terms, you're gonna ask, so there's that step right there. After looking at your first two terms, you're gonna look for the GCF there. So in this example, the GCF is x squared, so you write that down. You factor the x squared out, you're left with x plus 4. Then you do the same thing with the next two terms. So these two have a 6 in common, you write that down, factor it out, you have x plus 4. So now you're gonna factor out the common factor. So in this case, this has an x plus 4 in common, you write that down. And if you factor that out, you have x squared plus 6x, or sorry, plus 6 left. And that's your other factor. So what we started with, factors to x plus 4 times x squared plus 6. You're always gonna check any quadratic to see if it's still factorable. In this case, this is not factorable because two terms we know how to factor is a difference of squares, and that's a sum of not squares. Okay, so let's go ahead and try some examples. We'll do the first four together, and then you can try the last two on your own. The last two are a little bit more challenging, but it's good to challenge yourself. Okay, so the first term are not written as four terms. Basically what's happening is that it's giving it to you in this step, and it's moved to this step. So it's just the one step, okay? Just to make sure we have it. So if you look at this first one here, those two terms, this term and this term, have an a plus b in common. So we can factor out the a plus b. And then if you factor an a plus b out of this, you have 5 left. And if you factor an a plus b out of this, you have plus x. So there's your factoring. Also, if you look, this is not factorable after this. We don't have any quadratics. We don't have any GCFs in each of those terms, so it's all done. Similarly here, these two have an x plus 4 in common, so factor that out. And then I'll have x minus 3 left. And there it is, completely factored. Both are linear binomials, so from there, linear binomials with the lead coefficient of 1, so therefore they are not factorable themselves. Also, it doesn't matter which one you write first and which one you write second. You can write this one first or second, same idea in your answer. Okay, now here's where we actually start doing the whole process. So I see four terms, so I'm gonna try to factor it by grouping. I'll group the first two together, I group the second two together. Notice I'm taking the sign with the second two. Okay, so looking at the first two terms, I look for a GCF. They have a 2y in common. So I'm gonna factor 2y out of each term. I have y plus 2. Now I'm gonna do the same thing with the next two terms. So the next two terms have a positive 3x in common. Oops. Let's say I made a mistake and said it was only 3, right? Then I have 2x plus xy. These two are supposed to match and they don't, so I know that I made a mistake, right? Or it's not factorable, which a lesson on factoring by grouping, we're gonna have them factorable. All right, so it's 3x. You have 2 plus y. Y plus 2 and 2 plus y are the same thing. So we're gonna write down our factor of y plus 2, and then we have 2y plus 3x remaining as a factor. All right, one more, and then you can try the next two. Grouping the first two together, they have an x squared in common. X plus 3 left over. Grouping the second two together, they have a 4 in common. X plus 3. And then we have x plus 3 times x squared plus 4. If this was an x squared minus 4, then I would factor that to x plus 2, x minus 2, but it's not, so I won't. All right, go ahead and pause the video and try the next two on your own and then come back to see how you did. I'm gonna group the first two together. They have a 14 in common. That's 2 minus q. The second two, so I see that they have a q in common, but I'm gonna factor out a negative q. The reason why is because I want my 2 to be positive. right? So I'm going to factor out a negative q. I have 2, and then that gives me a minus q, which is what I need. Great news. So I have 2 minus q times 14 minus q. Second one here, group the first two together. They have an x squared in common. 5x minus 2. The second two, don't say they have nothing in common, because I can't say they have 0 in common. Factor 0 out, but they do have a 1 in common. So I'm going to factor a 1 out. And then I have 5x minus 2 times x squared plus 1. Once again, if it said, if this was an x squared minus 1, then I would continue to factor. Okay, I forgot to box this answer. I want it to all look the same. Okay, next, the last thing that we have to talk about today is the sum and difference of cubes. So we've talked about difference of squares before. For example, x squared minus 25 factors to x plus 5, x minus 5, right? That's a difference of squares. And we know that a sum of squares is not factorable on the real number. In the real number system, it's not factorable. On the imaginary number system, it's factorable, but not on the real number systems, okay? So for this next blurb right here, I'll say it better than what I'm trying to say. Similarly to the difference of squares being factorable, so is a difference of cubes. However, not only is a difference of cubes factorable, not only is the difference factorable, but so is the sum. And then here's a special factoring pattern. So really quickly, what a sum and a difference of cubes look like. The first one is a difference of cubes. Both are perfect cubes. Both terms are perfect cubes. And then it's a difference. Both are perfect cubes, and it's a sum. All right, so that's what they look like. And then here's a special factoring pattern. So when you have a cubed minus b cubed, that factors to a minus b times the quantity of a squared plus ab plus b squared. And then a cubed plus b cubed factors to a plus b times a squared minus ab plus b squared. Now, if you're not a formula person, which I am, but I'm not at the same time, I more think of like, how can I get this from this, right? That's how I think of it. So if you look at this first factor right here, a minus b, that is this right here, okay? So the first thing I tell my students is get their original cubed. So this has to be something cubed and this has to be something cubed. Then what you're going to do is copy the base. So this is the base right here, and you copy that right here. Okay? After that, you use that base to get everything else. So if you look, this is your first term, this is your second term. A is your first term, B is your second term. Don't worry about the minus in between them. You're going to square the first term, a squared. You are going to take the opposite of this sign, so this will become a plus. You are going to multiply these two things, AB. This is always going to be a plus sign, and then you square the second term, the last term. If you look, the same thing happens here. You copy the base. You square the first term, you change this sign, multiply these two terms, AB. This is always a plus sign, and then you square the last term. So how can we remember those words that I just said? I said square the first term, take the opposite of the sign, multiply those two terms, which is another word for that is the product. P stands for it's always a plus sign after that, right? This sign was always a plus sign, and then square the last term. Okay? So SOPs is the mnemonic device to help you remember. Square the first, take the opposite, product plus square the second. All right, so I'm gonna go ahead and do 1 and 2 with you, and then you can pause the video, try number 3 on your own, come back and see how you did. So first off, it has to be something cubed minus something cubed. So this is x cubed minus 125. So I'm gonna rewrite it as x cubed minus 5 cubed. So now my base is x minus 5. So I'm going to copy my base of x minus 5. And then to get my trinomial, it's SOPs. Square the first term, x squared. O, opposite. So take the opposite of that sign, plus. P stands for product. Multiply x times 5, which is 5x. P stands for plus. This is always a plus sign. And then square the last term. 5 squared is 25. And this is what it factors to. That's your special factoring pattern. X squared plus 5x plus 25 is not factorable. That trinomial you get will never be factorable. Otherwise, this wouldn't be the special factoring pattern, right? It would factor more if it was factorable. All right, let's go ahead and try number 2. So when I say get everything cubed, okay, I have my plus sign already. That's down. The x is already cubed, but the 8 and the 1 aren't. So 8 is 2 cubed. X cubed is already good to go, and 1 is 1 cubed. See that? All right, so I'm going to copy my base, 2x plus 1. And then remember, to get the trinomial, we're using this 2x plus 1. So S stands for square of the first term. 2x times 2x is 4x squared. O stands for opposite, minus. P stands for product. 2x times 1 is 2x. P stands for plus, always a plus sign. S stands for square the last term. 1 squared is 1. All right. All right, go ahead and pause the video and try the last one on your own. All right, how'd you do? 4 cubed x cubed plus 6 cubed. So we have 4x plus 6 times 16x squared minus 24x plus 36. All right. All right, that's all for today. You can go ahead and start working